All right, good people, welcome to the next video. We're still solving differential equations. I just want to keep reiterating the idea that what we're doing is they give us a derivative equation. We're looking for the solution of that differential equation, that derivative equation, which is the original function, the y equation. In the slope field section, we found the y curve, not the y equation. Here in this section, we're finding the y equation. How are we doing that? By separating the variables and then integrating each side. So here we go. Can you find the particular solution y of this differential equation given that f of 0 is equal to -1? Okay, so we're going to multiply both sides by dx. Once we do that, we have dy equals cosine of 2x times the square root of 7 minus 2y dx, because I multiplied this to the other side. But I have something that's in terms of y, so that needs to go to the other side. So I'm going to divide both sides by that. When I do that, I'm going to go ahead and just write it like this. And then this side, I'll write it whatever's left over here. So I'm supposed to take the antiderivative of this and the antiderivative of that. Remember that a square root is a 1/2 power, and that if it's in the denominator, it's a negative 1/2 power. So I'm going to rewrite this before I start taking antiderivatives. I'm going to rewrite this as 7 minus 2y to the negative 1/2 dy. So when I look at the left side and I look at the right side, I have an inside, I have an inside. So both of these are going to require u substitution. So I'm going to do u substitution, my little u substitution work over here, which says if u is equal to, let's say it's equal to this inside function, 7 minus 2y, then du is equal to -2 dy. And then this I can rewrite as -1/2 integral of u to the -1/2 du. And this is what I'm going to take the antiderivative of, right? And that equals, I'm going to do another substitution here, and I'm going to do this one in red. If my u is 2x, then my du is 2 dx. So then I'm going to be multiplying 1/2 times the integral of cosine of u du. I'm doing this because I have an inside-outside situation, and when I'm trying to take the antiderivative, I can't do that unless I use this u substitution. All right, so now I can take the antiderivative. The antiderivative of this side is going to be u to the 1/2 over 1/2, which is multiplying by 2. But don't forget, I still have this negative 1/2 that I'm multiplying there. And that equals 1/2 times the antiderivative of cosine u. Well, the antiderivative of cosine u would be sine u. Oh, let me do this in black. And let me do this u in red and this one in blue. There you go. Plus c. Awesome. So I have my general solution. However, notice I'm in terms of u. We started in terms of x's and y's. So I have to convert this back into what I started. So these twos are going to reduce, and I'm left with negative because these two go away. U to the 1/2 is really the square root of u in blue. My blue u was 7 minus 2y, and that equals 1/2 sine of u, my red u, was 2x plus c. All right, there's my general solution. I'm going to pause there to see if that makes sense. I had to do antiderivatives, but these antiderivatives had an inside function, so I have to do a u substitution, and that's what I did here. Once I'm at this point, I'm going to use my initial condition, this initial value, in order to find my constant. So I'm going to substitute 0 wherever I see an x. I'm going to substitute a -1 wherever I see a y. And let's see where this goes. Negative square root of 2 minus I'm sorry, negative square root of 7 minus 2 times your y equals 1/2 sine of 2 times 0 plus c. Well, 2 times 0 is 0, and sine of 0 is gone. So c is going to be whatever this is. Well, c, according to this, is going to be the negative square root of 9, which is just negative 3. Awesome! I figured this out. This is just negative 3, or minus 3. Now I'm ready to solve for y. So I'm going to take this, and I'm going to solve for y in a little bit here. But just to make sure, I'm going to wait to see if you, to let it kind of settle in what work we just did in purple over here. General solution, because it has a plus c. We use the initial condition to get the constant of integration. Now I have my particular solution. I don't have it solved for y yet, but that's what we're about to do. So now let's start undoing things here in order to get the y by itself. So I need to divide by -1 so that I can get rid of this negative. So now I have the positive square root of 7 minus 2y equals -1/2 sine 2x plus 3. Why did the signs change? Because I divided by -1 in order to undo this negative. And I'm going to square both sides. So now I'm left with 7 minus 2y equals all of this squared. And then I'm going to subtract 7. So I'm left with -2y equals all of this squared. By the way, some people would probably just do this. Plus 3 squared. And then I'm going to divide by -2. You can divide by -2 or just multiply by -1/2. And you're going to get -1/2 that times negative sine 2x over 2 plus 3, everything quantity squared. So I'm claiming that this is going to be the particular solution that we're looking for. And I know that this works because if I were to take 0, my x, and substitute it in here, I would get an answer that's -1. Okay. So the moral of the story is we're separating the variables, we're integrating both sides, we're solving for c, and then we're using algebra to solve for y. And that's how we can get to, oh, I'm sorry, I forgot the plus 7, didn't I? I was supposed to, I'm sorry, -7. Oh no, -7 here. And so really this should be -7 here. That makes more sense. I was wondering why something looked off. Yeah, I had forgotten the 7. -7, -7, and then divide by -2 or multiply by -1/2, but all of this was already there. This is the particular solution. Whoa, that seems like a lot. Separate and integrate. Whenever you're solving a differential equation, separate and integrate. Don't forget. We're going to look at 2008 here. This is an AB question, but it certainly could be a BC question. And I think this is the last problem in this section. They're giving us a differential equation. They're identifying it as a differential equation where x is not equal to 0. Why not? Because that would be a division by 0. It says on the axis provided, can you sketch a slope field for the given differential equation at the 9 points indicated? So here's what I'm going to do. I'm going to ask you to create the slope field. It says at the 9 points indicated. So 1, 2, 3, 4, 5, 6, nothing here, 7, 8, 9. And then can you find the particular solution to this differential equation given this initial condition? And then for the particular solution that we find, can you find the limit of f of x of that equation as x approaches infinity. So I'm going to give you time to do two things. Number one, draw this slope field. I don't want to take the time in the video drawing every single line. So I'm going to stop the video here. You draw it on your paper. I'm going to draw it on my paper, and then we'll compare. And then I'm also going to start the solution finding for part B. So let's take a break. Well, let's stop the video. And you do it, I do it, and then we'll compare.